Hello, and thank you for joining the Preseem Network Telemetry for WISP's webinar. My name is Gerrit Nagelhout, and I'm the CEO and one of the co-founders of Adalo Networks, the company behind Preseem. The title of this webinar is about network telemetry, but really the information is about quality of experience specifically for WISPs. I'll be covering a bit of background information about where we got our data from and the various metrics. From there, moving on to what is quality of experience, what's the definition of it, what does it mean to your business, and then examples of WISP's key performance indicators. And the main part of the webinar is real-world examples of various conditions that can impact the QoE in WISP networks. And I'll be finishing up with a very short Preseem overview. If you have any questions at any point, please type them into the Q&A panel, and I'll answer them at the end of the presentation part of the webinar. As a bit of background, Preseem is currently deployed and measuring quality of experience at hundreds of access points at WISPs across North America. We spend countless hours analyzing and interpreting the data collected from there, as well as figuring out the most intuitive ways to represent it. And the following slides really represent the highlights of what we have learned. Preseem works with any vendors and access points. It's really technology agnostic, but some of the popular equipment that we've seen are Ubiquiti, like Rocket M5s, Prism AC Gen 2s, Cambium's BMP 1000, 2000, 450, 450M, and lots more. So a bit of a definition. Quality of experience refers to how the network performs from the perspective of the subscriber. And the trick with that is the perspective of the subscriber is a very subjective thing. And what we try and do is take this very subjective element of it and turn it into a set of metrics that you can actually monitor in your network. And if those metrics are good, you know you're delivering a good quality of experience. The trick with traditional network monitoring, typically based on SNMP, is it monitors network elements, and it's very black and white. It often tells you it's something up or down. In reality, it's much more nuanced than that with the grayscale. Quality of experience, as perceived by your customers, is a combination of throughput, latency, packet loss, and service variation. And if any of these are out of whack a little bit, like too high latency or too high packet loss, the quality of experience will go down dramatically for your customers. If all these are good, you can deliver a good quality of experience, have happier customers, lower your churn, and lower your support costs. Well, it's kind of funny to say this, but really the best a piece of your equipment can hope for is not to make the QoE worse. You have, of course, optimization gear, and you want to make sure you have sufficient backhaul capacity and get the appropriate performance access points. But every hop and buffer along the way can add to latency, limit bandwidth, and introduce packet loss. This can be at the transit point, your routers, your backhauls, and your access points. And I'd like you to think for a few seconds about, in your network, what do you think the biggest source of QoE degradation is? What do you have to pay the most attention to in order to deliver a good quality of experience to your customers? So from all the deployments we've done, it's almost always about the access points. There are exceptions, and you can have backhauls with insufficient capacity. Your transit link can be congested, but by and large, the most problems we found are at the access points, and they're your weakest link. We found that for starters, the performance between different access points, even if it's the same model on one tower, for example, are very different. You can have very good latency in one access point in one direction, and the one next to it may have high latency and have all kinds of QoE issues. And the reason is there's many different factors that can impact the quality of experience delivered by your access point. We've seen lots of issues like congestion, interference, even adverse weather conditions, individual subscriber signal strength, even the mechanism you choose to enforce your subscriber plan bandwidth can have an impact on QoE. And really the key is figuring out which ones have the issues, what your issue is, and how to go about fixing it. Let's start off with a few key performance indicators. So the first one we're looking at is the per sector bit rate. So this is the downstream and upstream throughput achieved by the sector access point during peak hour. This number is useful for a couple of things. You can compare the overall throughput across different sectors in your network. You can also compare it against the theoretical performance it's supposed to have to see if it goes high enough. If you've got a Cambium 450M running at 50 megabits with high latency, you know it should be able to do much better than that. So it's important to keep that in mind. You can also compare the performance of different access point vendors and models. And one of the things this does is it gives you a clear upgrade path. Make sure you're not over-investing sectors with a low population density, but where it's required, make sure you put the right gear in place. And so typical numbers we've seen, the highest we've seen on any of them is about 140 megabits. It's a Cambium 450M. It was running pretty hot at that point, though, with quite a bit of latency. Typical numbers we see are more in the 20 to 40 megabit range. And again, this often depends on how many people, of course, are in that area. Upstream is usually about 10%, so 15 megabits peak upstream, and a few megabits is more typical than that. And the next KPI is similar, but it's now divided out per subscriber. So this is the average per subscriber download and upload rate for your access points. And the key thing here, of course, is if this becomes too small, whether to congestion or overly aggressive shaping, you'll get customers complaining about slower downloads or low resolution streaming video. And one of the key things to look at is to see how this compares across different access points in your network and making sure all of them are delivering a sufficient throughput for a good QoE. Typical average numbers we see are 1 to 2 megabit per subscriber download. Peak is around 15, and upload we've seen as high as 10, 11 megabits, but typically on average just in the hundreds of kilobits. And again, this really helps you understand which access points are not able to deliver sufficient QoE and need to be upgraded next. So per sector round trip time latency, this is one of the most important metrics that we look at. So this is all about the typical latency experienced by a subscriber. The way we measure with Preseem is it runs in line in your network. As traffic goes through our system, imagine TCP flow, the packet goes through our system to the end user's device and comes back again. We measure that round trip time. So it really tells you how long does traffic really take on your network. This is one of the most crucial metrics in how your customers experience your service. In some cases, even more important than pure bandwidth. So high latency can result in a number of problems. You'll get poor VoIP, so garbled calls, lots of lag and things like that. Real-time gaming will feel very laggy, but even browsing will feel unresponsive and slow. So to put this more concretely, to have a good VoIP call, you need to have an end-to-end round trip time. So that's your network, the intranet, and the network on the other side of the party they're calling of under 150 milliseconds. So your network is only about half of the equation. So therefore, you should always try and aim for under 75 milliseconds. If you can stay under that in your network, you can give everybody a good chance to have a good experience for those real-time protocols. One thing we've also seen is there's a very direct correlation between latency and bandwidth on an access point. So at a certain point, as you try and increase the bandwidth through an access point, the latency will go along with it. So increased latency is an early sign of congestion. High latency is a sign of you're definitely congested and need to worry about that. Typical access points that we see in a good range are in the 30 to 50 millisecond range, but we see many of them go as high as over 200 milliseconds. And at that point, again, the experience will be quite poor. Let's move on to the real-world examples now. So Sector congestion, this is the #1 issue that we've seen time and time again impacting QoE in WISP networks. So from a sector perspective, under congestion, the throughput is typically very high. It's running at full speed, but also the latency goes quite high, and this is what the issue is. So if you look at the charts on the left, the one on the top is latency by IP address. So every different color has a different IP address. We've blacked them out to make it more anonymous. And you can see it over time for one access point. So at the left, during off-peak hours in the morning time, latency is generally under 50 milliseconds, but during peak time at evening, it goes right to 200. An interesting thing is, you can see that all the latencies for all the IP addresses move in unison. So as the whole sector gets more congested, every single subscriber is now experiencing a higher latency because of the buffering involved at the access point before it can transmit it. And you can see at the bottom that the corresponding downstream bit rate goes up as well. And so in this mode, depending on how congested it is, your subscribers may or may not have good throughput depending on the level of congestion, but they will definitely have high latency. And again, they'll impact their voice in real-time gaming and browsing and lots more. So the way to fix this, you can upgrade your access point for if you have major congestion. If you just can't deliver the bandwidth you need to, this is a good, a good way to do it. If that's not an option or the congestion is fairly minor, I'd recommend putting on a shaper on a per access point to extend its life. So I'll explain a bit about how that works. So without any shapers, the access points have a large buffer that fills up, adds lots of latency, and a QoE gets decreased. When you put a shaper on, you don't want to just shape every single packet equally because now everything gets affected. The idea is you want to identify heavier streams like your Windows 10 downloads, your streaming video, and squeeze those down a little bit so that the resolution will go down a bit, the downloads will take a little bit longer, but everything else will still feel very responsive. And there's different ways to go about that. You can do anything from a DPI system, which is, as a advantage, gives you super fine-grained control of different protocols, but it's also a bit more expensive and it takes more effort to maintain it. We prefer a fair shaping type of approach where you have an algorithm that figures out automatically what the heavier streams are, regardless of what they are, and squeeze them down to make room for everything else. The next one we see quite a bit of is sector interference. So in a way, it's similar to sector congestion. Key difference, of course, is that with regular congestion, your throughput is high. With interference, basically what happens is the ability of the access point to transmit and receive data decreases, and therefore the bit rate is able to handle decreases, which results in higher and both an erratic latency as you're transmitting. So if you look at the chart on the left, this is the average latency for one access point. You can see for the first couple of days, June 12th and June 13th, the latency is great, under 50 milliseconds. The bandwidth is between 20 and 30 megabits and everything is good. All of a sudden on June 14th, even though the bandwidth didn't really increase, actually it went down a little bit, the latency all of a sudden spiked right to 200 milliseconds for several hours. And the next day, the same thing again. And it's also much more erratic and spiky. We pointed this out to our customer who looked into it and determined it was an interference issue, fixed that, and the problem went away again. So during this time, your customers will see much lower throughput and much higher latency. Best way to fix this, of course, is to deal with the interference, switch the channel, whatever you need to do. That's absolutely the best way to do it. Barring that, if there's really no way to do that, you can apply a per sector shaper as well to mitigate the impact and set it a bit lower to drive the latency back down. But in this case, it's really a bit of a band-aid. Storm moving through is kind of a less severe case of interference. You can see in the chart here for the first couple of days, again, the latency a little bit higher in the previous chart in this access point, between 50 and 100 usually. It went up even higher, up to 150 on July 3rd, as several rainstorms moved through. Subscriber impact is not quite as bad as interference, but they'll still have a bit higher latency and lower throughput. Really, the best way to deal with this is if your latency is under 50 milliseconds all the time under good conditions, even when a storm moves through and things get a bit hotter, you can still provide a good quality of experience. even under adverse conditions. Okay. This next one is really interesting. I think every WISP out there knows that if you do an installation for a customer that has a poor signal strength, either for distance or trees in the way, that customer will have limited bandwidth, higher latency, and get a bit poor experience. But you might still do it anyways because, hey, they have no other options and it's not a paying customer. The real question is, what does that one install do to the rest of your access point? Does it cause problems for anybody else? And so we went digging through our data to find some examples of that, and we found a bunch of good ones. And so if you look at the charts again here, same as before, one access point, different color lines are different subscribers or IP addresses on the same access point. And at the bottom, there's bitrate. So have a look at the one that's .13. It's blue on the top chart and a dark green at the bottom chart in a download bitrate. So you can see at the left, the .13 already has spikes of latency up to 200 all the time. That's pretty common. We see that pattern of high and spiky latency when there's low signal strength. But now look between midnight and 12:30 in the morning. At the bottom, the dark green shows a download, very high download rate, looks like about 7-8 megabits. But the overall download rate actually went down from 15 down to 10 megabits. At the same time, the latency spiked to over 200 milliseconds for that half hour. So this one subscriber with poor signal strength doing a high-speed download single-handedly dramatically affected the QoE of the entire access point. And so that's obviously not good for everybody else. People will be complaining about poor voice quality and all those things. And so the best way to fix this, of course, if you can address the signal strength, that's the best way to do it. Maybe you have a different access point at a different frequency you can put them on instead. Barring that, at least make sure they don't have a very high plan. The higher the bandwidth, the bigger the impact. And worst case scenario, and nobody likes doing this, but you may have to fire this customer in order to provide good service to everybody else. We have noticed some different behavior between different vendors. So this is a Ubiquiti example, which I believe is particularly sensitive to it. Cambium won't be quite as bad, but it'll still have an impact. This chart is also all about packet loss. Quick explanation here. So we measure packet loss through measuring the TCP retransmission percentage. So basically what happens is somewhere in the network, a packet gets dropped, TCP detects that and resends that packet again. And so one packet dropped could result in one or more TCP retransmissions. So there isn't necessarily a one-to-one correlation between packet loss and TCP retransmission, but definitely the higher the TCP retransmission, the higher the packet loss. So for good networks, typically we see 2 to 4%, which is quite good. In this case, you can see it typically hovers between 10 and 15%. And even though it goes up and down a little bit, it's actually fairly consistent throughout the day. It's not like during peak hours, the packet loss is much higher and causing issues. It's something that's happening all the time. And so we dug into this a bunch and realized it was actually happening due to the plan enforcement mechanism in this case. So this particular customer was using Radius to signal to the access point what bitrate a subscriber was allowed to have. And rather than putting in some kind of smarter shaper, the Cambiums do a strict limiting. So as soon as the bitrate is achieved, it starts dropping packets whenever it goes over that. And the problem with that is it results in quite a high drop rate for that customer. It also results in lots of extra data on your transit link because all these retransmissions have to go all the way over your network again. And you might say, well, you know, that customer has maxed out their link. They should be getting hit a little bit. The problem is it can cause you lots of support issues. Let's say, for example, that a Windows 10 download is causing them to hit the maximum rate on their network and on their connection. And let's say it's 5 megabits. It takes up to 5 megabits. This limiter starts kicking in. It starts dropping packets randomly. If they're doing anything else, like browsing, VoIP, real-time gaming, they'll have a very poor experience on those protocols because of what the Windows 10 download was causing. So really recommend against doing any kind of limiting at the access point. I know Cambium works differently from Ubiquiti, but none of them do a great job on it, so we suggest putting on an external shaper to do it. That's really the best way to fix this issue. And this is one example of something that's not due to the access point, but it was interesting to show because it really fits in here. So in this case, there's actually a backhaul congestion. So if you look on the bandwidth chart on the top left, this is a 24-hour period, and you can see that the bit rate during off-peak hours is a bit lower, so 30, 40 megabits, but it spends many hours a day hovering around the 60 megabit mark. And by the way, the blue versus the green line is the averages, so every sample is like 5 minutes. Blue, we show the instantaneous peaks that we saw every 10 seconds and that we can do with our measurements. So they're pretty close, but you can see some spiky behavior there as well. But yeah, so it spends many hours at 60 megabits. And typically what we see is much more of a curve, or during peak hours, it spikes much higher. But you might say, well, maybe this access point has a bunch of commercial customers on it. I'm not surprised to see it maxed out that long. But now if you look at the packet loss right next to it, you can see during off-peak hours, at the bottom, it's between 2 and 4% normal range. But around 3 in the afternoon, it starts being 5. And from there, creeps up steadily to 15% during peak hours. So during the peak hour, there's a 15% TCP retransmission rate. Again, very high packet loss. And that's simply happening because the demand for bandwidth is much higher than the 60 megabits that's available. And there's no shapers in place in this particular setup. So it is simply a choking point where traffic randomly gets dropped. This will have a major impact on subscribers, lower bit rate. The browsing will feel very unresponsive, very poor VoIP, all the usual factors, but quite severe in this case. Best way to fix it, if this is simply a network issue of some kind, fix that. See if you can increase the capacity when it's this severe. If not, at least put on some kind of fair shaper on this link to address it nicely, rather than just randomly dropping packets and killing QoE across the board. Speaking of shapers, there's a couple of things to watch out for with external shapers. One of the main ones we've seen is shapers adding excessive latency. So if you look, top chart again on the left is latency for one access point, where every color has a different IP address, and the bottom, the corresponding bit rate. The way this chart is laid out is we do the top 10, and then the others category is everybody else. So if you look at the others category, you can see it's generally hovering on 50 milliseconds, which is quite good. But the orange and light blue lines, which is .38 and .104, have way higher latency, up to 150, even 200 milliseconds. And that's because they're both heavy bandwidth users. They've maxed out their planned bandwidth, and the shaper is adding a lot of latency. And in this case, the queue depth is simply too high. It's adding way too much latency to those particular subscribers. You want something much less than that. And ideally, rather than a simple shaper, you want something that's a fair shaper, which again, I think it impacts your heavier streams more than the lighter streams. Whether that's through DPI or a simpler fair shaping mechanism, either way is okay, but you need to do that somehow to drive the latency back down. Because in that state, let's say that household has one person watching Netflix, driving the latency up, everybody else will get a poor experience as well, resulting in extra support calls. Way to fix this, decrease the queue depth on your shapers, make sure they're tweaked correctly. Apply different kind of shaping, again, like a fair shaping or something like that, or if required, upsell your subscribers to a higher bandwidth plan. Okay, that's it for the real world examples. I'll spend a couple of slides on what Preseem, the product, does, and then I'll start answering any questions you may have. So Preseem in 4 bullets. Preseem runs on an inline Linux server. It's typically deployed just south or on a subscriber side of your edge router. And then all the traffic goes through it, where we have visibility into each IP address. We then measure the quality of experience delivered by your network to your customers. So we measure and store and analyze the key metrics like latency and packet loss that I showed in throughput for every IP address every 10 seconds. And we log that in our cloud-based platform. We can also correlate that to access point, tower, and to be able to correlate and trend things over time and see where the issues are. And from there, we can provide specialized insight to different functional groups within your organization, operations, support, marketing, sales. We have different tools for different groups to use. And we also provide tools to improve the QoE through inline traffic management. And you heard me talking about fair shaping a few times. That's one of the key ways we do this. We can apply a fair shaper on a per subscriber level, on a per access point level, or congested backhaul. And again, the idea is to take heavier streams down a notch and make sure everything else goes through at good quality. And so the key difference between the way Preseem measures this versus other tools like SNMP and ICMP is that the Preseem QoE metrics are derived from the actual subscriber's traffic and therefore provide insight into the real subscriber experience. You also never, you can't not measure a link along the way because it doesn't matter. It doesn't matter how many links it goes through. The round trip time latency just adds them all up. And so if the QoE from the data delivered is good, you know all your network elements along the way are doing their job. If something is out of whack, something in your network is causing problems. And so traditional techniques such as ICMP and a path are useful, but there's a couple of issues. So first of all, the sample rate is typically every 1 to 5 minutes. This isn't accurate enough to do a good correlation and see where the issues are coming from. They're also not accurate if you have network elements that treat TCMP differently from ICMP. So Ubiquiti, for example, has a habit of short-circuiting ICMP packets straight through, even though TCP is getting buffered. So if you look at ICMP, you're not really getting the real story of what your customers are experiencing. And last but not least, they can't measure the QoE down to the end device in the home. When you look at the traffic and they have a problem with the Wi-Fi network in their home, that'll show up in the metrics, whereas with ICMP, it doesn't. Okay, so that's the end of the presentation part of the webinar. If you'd like to learn more, or book a private demo, or just have a call, you can click. I believe you can click on the presentation here to get the link. I'll also put the meeting link in the chat channel, and I'll start answering any questions you may have now. Okay, the first question from Mitchell. Will today's 30-minute session be equivalent to scheduling a demo? It's quite different. I really tried to focus on more of the issues found with QoE in your networks rather than doing a walkthrough of how Preseem deals with them. So if you want to see that aspect, please schedule a demo or call with me to go through that. Next question for Jeremy. Do you have a strategy for managing LTE traffic that runs through a central ENB and is not easily associated with a single sector? Yes, we do. We've got a couple networks that have LTE already. Probably best to book a call to get into the details of how that's done, but it's definitely possible.